Do you know your medicine?
Weed Maps and SC Laboratories bring you an educational series on the science of clean and safe cannabis. Today's cannabinoid profile is on cannabidiolic acid.
CBDA, or cannabidiol carboxylic acid, is an acidic cannabinoid. Acidic cannabinoids are what is actually produced by the plant.
It's a precursor for CBD, cannabidiol. It's the acid form. And again, just like THCA changes to THC in the heating process, CBDA changes to CBD with the heating process. Interestingly enough, CBDA also has been found to have some properties of its own, and one of the properties that it's been found to have is what we call anti-proliferative, meaning it helps prevent cells, especially cancer cells, from proliferating. It also appears to have some anti-inflammatory properties as well. Not a lot of studies have been done on CBDA, but there are some patients using it for its anti-inflammatory and anti-tumor properties. And again, they're using it in the raw form, CBDA form, and usually processing that in juice or some type of food without heating it up, and so that it stays in that natural raw form without changing to CBD. Certainly it warrants much more research, as it may have benefits beyond that we already know.
CBDA is a part of the acidic class of cannabinoids, including THCA, CBCA, THCVA. The acidic cannabinoids are produced in the plant from a common precursor known as cannagibberellic acid. Cannagibberellic acid is CBGA. Through different enzyme catalyzed reactions, you will make CBDA from CBGA with a CBDA synthase, is what the enzyme's called. And enzymes are what allows cannabis plants or any living thing to make new chemicals in conditions which otherwise would not support that chemical being produced. Here we have the synthetic pathway in the plant by which CBDA is produced. We start out with geranyl pyrophosphate and olivetolic acid that combine in another enzyme catalyzed reaction to form the cannagibberellic acid, or CBGA. And this is the structure of cannagibberellic acid, and you see this long chain of carbon molecules. These carbon molecules are able to bend in and form rings and other structures that allow it to be the precursor for all these other compounds we see. The compound of interest right now is CBDA, which is made by the CBDA synthase, and here's the structure of it. It's very similar to THC, which we all recognize, except for with THCA, this ring has closed. With CBDA, the ring is open, and we have this carboxylic acid over here, the COOH. The COOH will release at about 80 degrees Celsius, and it'll release itself as carbon dioxide and form CBD. SC Labs tests for CBDA using high-performance liquid chromatography. We use this over the other method that is in common practice, GC, or gas chromatography. The problem with gas chromatography is it uses heat in the process, and as I said, the heat takes CBDA and makes it into CBD. So the problem with gas chromatography is that you can't get any information at all on the amount of CBDA that's actually in the plant. And it's very important to know because there are very different effects in the body between CBDA and CBD, especially if you're eating the product or you're not smoking the cannabis. You're not going to convert that CBDA into CBD, so it's going into your body as CBDA. With the information on CBDA, patients can make a much more informed decision on what cannabinoids they choose to ingest into their body and what effects the cannabis is going to have on them. There hasn't been enough research on CBDA. CBD has received quite a bit of research. CBDA, the results that are out there are pretty promising. So hopefully with the testing that SC Labs is doing here, it'll inspire more researchers and breeders and patients to take notice of CBDA and really unlock the true potential of this cannabinoid.